So far in this series, we have understood how OneLake solves the storage problem by giving every workload a single unified data layer. But storage is only one part of the story. The next question is, where do all these fabric objects actually live? Where do we create lakehouses, warehouses, pipelines, notebooks, reports, and who gets the permission to access them? And another equally important question, what actually provides the compute power to run all these workloads? To understand that, we need to learn two of the most important concepts in Microsoft Fabric, that is workspace and capacity. Let's start with the workspace. A workspace is simply a collaborative container where your Fabric assets are stored. Inside a workspace, you can create lakehouses, warehouses, data pipelines, notebooks, semantic models, reports, dashboards, and many other Fabric items. But a workspace is much more than just a folder. It also defines who can access those items. Every workspace has its own users, permissions, security, and ownership. So, whenever a team starts working on a project in Fabric, the first thing they usually create is a workspace. Now, let's talk about capacity. As we have already talked about workspace, which only organizes your project and your team, we will need to understand how workspace gets its compute power. The actual compute power comes from something called capacity. Every workspace is assigned to a Fabric capacity. That capacity provides the CPU, memory, and compute units required to execute notebooks, pipelines, SQL queries, refresh semantic models, and every other workload running inside that workspace. Let's understand this concept with the help of an example. Think of it like an office building. The workspace is your office floor. That's where your team sits and where all your project's files are kept. But an office floor cannot function without electricity. The electricity comes from the building's generator. In Microsoft Fabric, that generator is called the capacity. So, workspace equals the office floor, capacity equals the electricity generator. Now, let's talk about F-SKUs as well, which is associated with capacity. As in real life, not every generator is equally powerful. Some are small, some are huge. Similarly, Microsoft Fabric offers different capacity sizes called F-SKUs. For example, an F2 capacity provides around 2 compute units, an F16 provides 16 compute units, while an F64 provides 64 compute units. The bigger the capacity, the more workloads it can execute in parallel. One interesting thing is that multiple workspaces can share the same capacity. Imagine a building with 5 office floors. All 5 floors are connected to the same electricity generator. Exactly the same thing happens in Fabric. Multiple workspaces can run on a single capacity. Let's understand this with ADF analogy as well. If you have worked with Azure Data Factory, this is actually very similar. Think about integration runtime. If several pipelines start running at the same time, they all compete for the same integration runtime resources. Fabric works in a very similar way. If multiple workspaces share one capacity, then every notebook, every pipeline, every SQL query, every Power BI refresh is competing for the same pool of compute resources or units. If you are finding it difficult to understand or remember all these things, here is an easy way to remember what a workspace actually represents. Just remember the word trip. T stands for team. That's who has access to the workspace, like admins, members, contributors, and viewers. R stands for resources. These are all the Fabric items stored inside the workspace. I stands for identity. Every workspace has its own OneLake location and identity. P stands for power. Every workspace is assigned to a capacity that provides its compute power. So, whenever someone asks you what a workspace is, just remember team, resources, identity, and power. Also, similar memory trick for capacity is think capacity like a fuel tank. An F2 capacity is like a small bike fuel tank, F16 is like a family car, F120 is like a heavy truck. The larger the capacity, the more compute it can provide and the more jobs can execute simultaneously before the system starts throttling. Now let's look at this from an architect's perspective. During interviews, you are often asked, how would you design workspaces in Microsoft Fabric? There are three common design patterns every solution architect should know. The first is environment-based design. Every project gets three workspaces like dev, test and production. Usually dev and test share one smaller capacity while production gets its own dedicated capacity. The second pattern is domain-based design. Like finance team has its own workspace, HR team has its own workspace, sales team has its own workspace, and marketing team has its own workspace. Every business team owns its workspace independently. And the third pattern is the hub and spoke model. Here, one central workspace stores common assets like master data, shared dimensions, and reference data. Business workspaces don't duplicate this data. Instead, they use OneLake shortcuts to access the same shared datasets. Here is one golden rule I always follow when designing enterprises fabric solutions. Never run your production workloads on a shared capacity. Imagine your production pipeline is processing millions of records, while at the same time a developer starts running a massive Spark notebook in the dev environment. Since both workspaces share the same capacity, they compete for compute units. Your production pipeline may suddenly slow down or even get throttled. That's why production workspaces should always have their own dedicated capacity. Let's discuss real interview scenario. Suppose an interviewer asks, design Microsoft Fabric for three departments, finance, HR and sales with separate dev, test and production environments. What would be your answer? The ideal answer would be that we should create 9 workspaces, 3 teams multiplied by 3 environments. Use one shared F8 capacity for all dev and test workspaces because they are non-production. Then assign a dedicated F32 capacity to each production workspace. Finally, if there is a team which handles central DW core workspace to store shared master data and let every business workspace access that data through OneLake shortcuts instead of copying it, then we will create 3 workspaces for that too. This design improves governance, reduces storage costs, prevents interference between teams, and scales much better for enterprise workloads. Let's further extend this discussion considering OneLake in picture. Although we have 12 different workspaces, we still have only one OneLake. OneLake is shared across the entire Fabric tenant. It is not created separately for every workspace. Instead, every workspace simply gets its own logical folder or path inside the same OneLake. Now, did you notice those separate folders in OneLake at bottom? You can actually think of these as folders inside OneLake. Finance development has its own folder, finance test has another, finance production has another. The same is true for HR, sales and even the DW core workspace. So the storage is unified while the workspaces remain logically isolated. Now let's see how data sharing works. Suppose finance needs customer master, HR needs employee master, sales needs both customer and product data. Earlier, organization would copy these datasets into every team's storage. But in Microsoft Fabric, we don't need to do that anymore. This is called zero copy. Instead, every workspace creates a OneLake shortcut pointing to the data inside the DW core workspace. The data stays in exactly one location. Multiple teams simply reference it. And if we talk about the benefits, because there is only one physical copy of the data, the storage costs go down, governance becomes much easier, security is managed centrally, and every department works with exactly the same trusted data. So let's quickly recap what we have learned in this chapter. We learned that a workspace is where our team collaborate and where all Fabric items like lakehouse, warehouse, pipelines, notebooks and reports are organized. We also learned that a workspace does not provide compute power by itself. Every workspace must be assigned to a capacity. Multiple workspaces can share the same capacity, but production workloads should always use a dedicated capacity to ensure predictable performance. Most importantly, we learned that no matter how many workspaces we create, they all share the same tenant-wide OneLake. Every workspace simply gets its own logical folder inside OneLake, and data can be shared using OneLake shortcuts without creating duplicate copies. That's one of the biggest architectural innovations in Microsoft Fabric. But before we wrap up, here is one practical question. If every workspace needs a capacity, which capacity should we actually buy? What is F2, F8, F64 or F28? What's the difference between F-SKU and the older P-SKU? And if you are just learning Microsoft Fabric, is the trial capacity enough? These are some of the most common questions in Microsoft Fabric interviews and real-world projects. In the next video, we will compare F-SKU versus P-SKU versus trial capacity in detail. We will understand how compute unit works, how Microsoft charges for capacity, which SKU is best for development, testing and production, and when you should choose one over the another. By the end of the video, you will know exactly how to select the right capacity for any Microsoft Fabric project. So, I will see you in the next one. Thank you. Before we wrap up, remember that this series is intentionally architecture first. Here we focus on concepts, design patterns, and the reasoning behind every architectural decision. Once we have built that foundation, we will start a separate hands-on implementation series where we will build everything from scratch inside Microsoft Fabric. Because great data engineers know the tools, but great solution architects know why the tool exists. And that's exactly we are building together in this series. I will see you in the next chapter.